So yeah, today I wanted to talk about distributed tracing made easy with .NET Core 3/.NET 5. I don't know where things are at this point, and OpenTelemetry. It is a little disingenuous because it's distributed tracing made easy. I should say relatively easy, because anything with distributed in the name is never going to be just like dirt simple easy. But at least it's now relatively easy than it was before. So you can find me on Twitter at @jbogard. This presentation and all the code as well is on my GitHub, and I'll share a link to this specific code example here later. And that's more other junk about me that no one cares about anyway. Okay, so first I want to talk a little bit about why we care about distributed tracing. I should warn you that if you've never had to deal with distributed systems, you wouldn't really care about distributed tracing. But then if you're dealing with distributed systems, then suddenly you care a whole lot about distributed tracing. So if I kind of go back to the quote, good old days, in the good old days, we would just have a single app, a single executable running our system. And if everything was okay, then the people are using the application, everything works fine. Now, if something goes wrong, we get an exception. And part of that exception includes a stack trace. And that stack trace is it's a trace of calls to show where we got that exception and all the calls that led up to that place where we finally got that exception. So hopefully we can use that information to figure out where the bugs are in our system, fix the bug, redeploy our application, everything is okay. So that's a stack trace that's inside a single application. Now, these days, I don't deal with just an individual application. I deal with distributed systems that are multiple applications, all communicating with each other in various ways. So if I have something blow up way down here after the chain of calls, that stack trace is only applicable to that one single application. So for my API, I don't necessarily see how that exception occurred, nor do I see how that exception relates to that initial request. And so that's where distributed tracing comes into play. Distributed tracing is there to be able to connect all these different boxes and all the different arrows. And it's kind of ingenious how the different product companies have come up with a way to be able to connect all these different pieces together. And the basic idea is to build a sort of graph of all the different requests and different activities that have happened in each of the different systems. And so each thing that happens in a system, each request is assigned some kind of identifier, and that uniquely identifies that individual request. Now, if that request makes some other call to some other service, however that may happen, I need a way to link those two requests together. And the way we can do that is with a simple kind of linked list. That is, whenever I make a call from one system to the next, what I do is I'll pass through the ID of my request to that subsequent call, so that subsequent request has information about who made this initial request. And so it becomes kind of a directed acyclic graph. So if you're big into Git, it's kind of like that, where I have a graph of calls of all the different processes in my system. And so as long as when I'm working with one specific activity in my system, as long as I have that parent request identifier, then I can put these different pieces together to say, if something goes wrong, or if I just want to see what the heck's going on in my system, then I can use these different IDs to try to piece everything back together again. So with this kind of concept, a lot of companies and open source projects came forth to help try to solve this individual problem. So something like Zipkin. Zipkin is a product that came out of some company, I forget who, maybe Netflix or one of those. And so they solved this problem by attaching headers to each HTTP request as API calls were getting made throughout the system. And they invented an extension header for this x-b3-span ID, very important, to identify that request as well as identify the parent request as well. So as these requests get made through the system, something can look at these very special headers to figure out how these different requests stick together. Now, this introduces a problem, because if I want to replace Zipkin with something else like Jaeger or Dynatrace or App Insights, each of them has a different way of representing these IDs and parent IDs. And so in order to standardize the different ways I can represent an identifier and a way to link back to the parent identifier, the W3C consortium with folks from all these different companies got together and came up with a standard called trace context. And trace context is the standard for identifying individual activities through an identifier, as well as propagating the parent ID information to subsequent services. And that parent header is just called trace parents. And the other piece we have going on here is when I have a request coming in and I need to uniquely identify this request, then that results in an ID assigned to that activity. And so that piece is the activity API from .NET. Now that activity API has been around for a while. And so some of the work that's being done in .NET Core 3 is to conform to the W3C standards for what that ID needs to look like. Now, what about non-HTTP requests? So in the previous picture, we had the W3C trace context standard, which really is describing HTTP requests. But in the distributed systems that I deal with, it's not just HTTP. It's HTTP, it's AMQP with something like RabbitMQ or Azure Service Bus, and maybe gRPC as well. And so the W3C folks says, right, okay, this standard defines what it looks like for HTTP, but also here's some other ways you can represent that same information in other systems. Like gRPC wants to have their headers compacted as much as possible. So here they have a way to say, well, here's how the ID needs to look for that as well. So in a distributed heterogeneous system where I have a lot of different kinds of communication, then we will have to have ways in order to make sure that that context flows through all the different kinds of communications in my system. Now, it's not enough just to have these IDs flow through the communications in my system. When something happens in my system, I need some way to notify something that's listening to that to say, this something has happened, here's the ID of the thing that's happened, and here's the parent ID of the thing that's happened. So in the past, the way we would report traces is either by installing some package in each of our applications or having something listening to all the communication of those different pieces going back and forth. So an application listener like Zipkin can be installed in each of our applications, or it can be installed kind of around them, either through something like sidecar containers or just something in our environment that's listening to all the different arrows and then reporting back to a central server that says, here are the traces that are happened, and then have one place to go through to then view essentially a distributed stack trace of an overall request to my system. So that's great. You know, we want to do Zipkin. We just have to make sure we have those Zipkin special headers going around everywhere, and we have those Zipkin special hooks into all of our applications, or the Zipkin special listeners going on. But new CTO comes in, he says, right, Zipkin's ugly. I don't want to do Zipkin, I want to do Jaeger. Jaeger's much cleaner looking, much nicer, and we're going to all switch to that. So great, now I have to go through all these different applications, change the headers to something new, change the list to something new, blah, 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 blah. And so that's where OpenTelemetry comes into place. OpenTelemetry is an effort to standardize the tracing and span information that comes out of all these distributed traces into one common format. Now, OpenTelemetry is a combination of some previous efforts to standardize around some of these APIs from OpenSysnis and I think another one as well. And its overall goal, you can kind of think of it like how Microsoft standardized some of the APIs around logging, dependency injection, configuration. This is an effort to standardize the APIs around telemetry information. So if I can target that common telemetry API, then these other exporters like Jaeger and Zipkin can just hook into that common API. And now if I want to, I can switch from Zipkin to OpenTelemetry. It's even more important that if I'm a developer of some kind of infrastructure component, like the database infrastructure components or communication components, I don't want to target all these different all these different tracing visualizers. I want to target one API, just publish out one package, and then have everyone be able to use any of the different visualizers based on that common API. So if I'm a tool vendor that wants to expose traces, I don't want to have 15 different visualizers I want to support. I want one I want to support, and then you hook in the visualizer, however whichever one you want to do. So what is our demo going to cover today? We're going to cover three main things. The first is looking at how we can use activities to propagate that W3C trace context information for new kinds of communication in our system. We're going to be using OpenTelemetry as the listeners for those activity information to be able to standardize that span and trace information. And then finally, I'll demo Jaeger and Zipkin as OpenTelemetry exporters to show how a single trace in my system can be visualized in those two applications. All right, so I'm going to swap over to Visual Studio. Okay, so I'm showing Visual Studio, and inside this application, I've tried to simulate a complex distributed system, which is not as easy as you might think. But I wanted to try to simulate as many different kinds of things in my client work that I see on a daily basis. And so this application is showing API type endpoints. It's showing messaging endpoints using RabbitMQ. It's using databases, so it's using a SQL database, and it's using a MongoDB database as well. So I think I checked like all the boxes of all the different kind of microservice-y things you can do, except it's not running in Kubernetes, so I missed one, I guess. So anyway, so this is just a bunch of .NET Core 3.1 applications. So they're not too terribly different. They're targeting .NET Core 3.1. And the first thing I want to do is opt in to the W3C identifier format for all of those trace IDs that flow through my system. This is the thing I'll probably forget the most to do. And so before my application starts, I have to set the ID format to be W3C. And what this is just telling the system to do is whenever you create new activities, which represent some unique request in my system or unique, interesting thing, is to not use like your own ID format, which might be like GUIDs or something, but use this standardized format for your IDs. Now, out of the box, .NET Core 3.1, if I light up this W3C tracing format, then all requests in and out of ASP.NET Core will include this standard W3C trace header with this format. Additionally, any calls I make outside of that, so if I have an incoming web request that makes an HTTP call, then those HTTP calls will also have that trace header information piggybacked along with it. But it's just HTTP. So what I wanted to do was show what would this look like if I wanted to piggyback on top of additional kinds of communication. And this application in particular uses messaging in the form of RabbitMQ. And I'm using a wrapper on top of RabbitMQ, a library called InServiceBus, which just makes my life a little bit easier when dealing with RabbitMQ. And so what I want to do is hook into that pipeline to be able to propagate this header information from the current activity into any outgoing call. Now, the code that I'm going to be showing here is going to be very specific to this activity API. And that's just the API inside of .NET to standardize around how I surface diagnostic information. So let's show that first. So over on the right, I've got a library that is referencing two things. One is InServiceBus. This is just for wrapping our messaging components. And the other thing I'm referencing is the system diagnostics diagnostic source. And I'm targeting NET Standard 2.0. So I can use this from anything that can support NET Standard 2.0 can use this library. So I need two pieces here. The first is incoming requests. I need to make sure that I grab any kind of incoming header information off of those requests and stick them in one common location. That common location is an activity. And so that is a piece of middleware here. And this middleware is specific to InServiceBus, but you can kind of think of it as similar to filters and ASP.NET Core. A lot of different kind of infrastructure components have some way to provide instrumentation or wrap individual activities of things going on underneath the covers. So this does three things. First, it wants to start an activity based on the incoming context. It's going to wait for the next thing to finish, which would be handling the message. And then finally, it's going to stop the activity. Now, starting the activity down here, it needs to do a couple things. The first thing it needs to do is pluck off the incoming header information from the incoming message. And so what it's going to do is take out the trace parent header, which is going to be this trace parent header name. So that's the W3C standard for the header name, and put that into a variable. And then when it's, after it's created the activity, it's going to set the parent ID of the current activity to the request ID that came in from the incoming request. So this activity has its own ID that got generated and has a parent ID of whatever the incoming request was. There's a bunch of other junk that we won't cover, but the last piece we need to do is to start the activity. And this starting the activity will surface out diagnostic events to something that is then going to listen into those diagnostic events. Okay, so that's part one, was plucking off the incoming header for taking the incoming header's parent and being able to attach it to the current executing activity. The next piece is propagating that trace parent information to outgoing messages. So that's this piece. We're going to use the same exact activity API, except this time, instead of taking header off of the incoming message, we're going to inject a header into the outgoing message. So for this code, I'm going to take out, here we go, the activity, the current executing activity's ID, and going to set the outgoing trace parent header. So I look at my current activity that's executing, and I'm going to, for the outgoing message, stick the current ID as the new parent ID for whatever is going to be going on the other side there. And so the key here is that everything is flowing through this currently executing activity. And how do I know what the currently executing activity is? That is actually pulled from activity.current. Current. There it is. Okay, that is the currently executing activity. So when I start a new activity, I'm able to take the current activity, set its parents, and it creates an in-memory graph of all these different activities. Okay, so let me just run this one web application by itself. Actually, first, let me trace through what this looks like. So I've got a web application, and this web application has two actions on it. The first action is going to be sending a message to a downstream process to be able to process the information. And the other one's going to be publishing the event. So I wanted to highlight what the difference between sending a message to a specific queue would look like versus publishing an event that could be published out to multiple queues and multiple endpoints. The receiver of this first one is in a separate worker service. And this worker service actually starts off a process manager or Saga. I won't go too much into this code other than to say this is going to be kicking off a complex set of communications between this one's going to send a message to get some information, a new message. This message is going to make an API call to something else. This API call is going to call into SQL to get some SQL information. That's going to return back some information. And then finally, this one's going to call another set of things to call. And that other set of things is going to call MongoDB to do some yet more stuff to get some information. And so I make a call, it calls RabbitMQ, that sends more RabbitMQ messages out, those make API calls, those make databases calls, pulls it all together again, does another RabbitMQ call to say, the final result sent to the web application is this. It says, okay, I received your message, and here's the actual message I received. So trying to combine as many different things running as possible here. Okay, so let's just run our one-up web application. I'm going to, just through Swagger, execute this one endpoint and show what this looks like in RabbitMQ to see that trace parent being attached to all the outgoing requests. Okay. Our lovely wheel of death going here. All right, our application is up and running, and we should see Chrome prop up with my Swagger UI, and I'll execute the endpoint to be able to initiate that request. Eventually. There we go. Blah, 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 blah. Okay, some startup logging. Okay, here comes Swagger. All right, so let's go ahead and execute this first request. Hello, build stuff. Execute. Okay, so behind the scenes, that is sending the message out the door. But now nothing is listening to it yet because I haven't started the other worker processes. So I can switch over to RabbitMQ, and we can see some messages in the queue. So this is our worker service queue. It has 2 messages, one's from previous in the day. And if I get the messages, we can see down here, yep, here is our trace parent header that includes that whatever is that the trace parent's W3C format is, that is being propagated out now to all my communication through messaging and receiving and then propagating it out again as well. So let's go ahead and stop this and go to the second piece, which is going to be, I've surfaced out some diagnostic information in my code where I'm going to start and stop the activity. The next piece I need to do is surface diagnostic events. And the way we surface diagnostic events is through the second API, which is known as a diagnostic source. Diagnostic source is also from the system.diagnostics namespace, and it's the way that your code can surface any kind of diagnostic events. And for something that's a distributed system, this is preferred over logging. So logging is something that just goes to a single log source. But a diagnostic source lets me attach that to other diagnostic events and activity information to be able to correlate all those different pieces together. So instead of me just logging to a file, I'm going to raise an event through this diagnostic source down here. There we go. Diagnostic listener.start activity. That's going to raise a diagnostic event called start with this payload that'll let me listen to it somewhere else to be able to say, okay, I want to now process that diagnostic event and then record it somehow. So the second piece is going to be translating these diagnostic events into OpenTelemetry. So OpenTelemetry is that standardized library for defining what spans and traces look like, which is not the same as the activity API, because activity API was not designed for this. So this is translating between the activity API and the span API that is the standard for distributed traces. And I'm referencing a package, OpenTelemetry, and you can see over here that it is alpha right now. Some of the other packages are in beta, so by the time .NET 5 rolls around, this will all be released to 1.0. For now, they're still iterating on it, and it's just an alpha. So my adapter is an OpenTelemetry hook that translates between the diagnostic source events from the activity API into a subscriber that listens to that events and translates that into OpenTelemetry. And so that's what I have here, this adapter that's going to translate subscriptions to diagnostic source events into this listener that's going to translate the activities information into span information. So down here, I translate the activity and the payload of that activity into a span, and the telemetry span is the OpenTelemetry standard. So I won't go into the code behind the scenes there because it's basically translating activity data into span data. But what I'm doing there is translating some of the information on there into some standard information that I want to put as part of my span, so that when I see that span in a user interface, I can have all the kind of telemetry data as part of that. So I start the span whenever the activity starts. I stop the span whenever the activity stops. And underneath the covers, OpenTelemetry will translate those start and stop spans into something that they can be exported to any kind of user interface. So the last piece for us is going to be, we've got the activity in place to be able to put the tracing information. I've got diagnostic plugs and hooks to be able to take that incoming trace information, put it into activity, and then propagate it into outgoing stuff. I've got a listener that listens for those diagnostic events and outputs OpenTelemetry information. And the very final piece is to then attach exporters to these applications so that it can listen to those OpenTelemetry spans being generated and output them into something. So if I go look at my individual applications and the configuration, let's go to child worker service. That'll look basically the same. So in this child worker service, down at the bottom, I've got a piece where I configure OpenTelemetry. So that extension comes from an OpenTelemetry package to hook up OpenTelemetry into the service collection. Gives me a builder. I hook up first some listeners or exporters for that OpenTelemetry information. I've got 3. I won't show App Insights because it's ugly. Zipkin and Jaeger look nice. Jaeger, not Jaeger. So Zipkin and Jaeger, I configure the API endpoint URLs and the service name of whatever the service is. So it shows up nice in the user interface. The next piece I need to do is attach all the adapters. And these adapters are the things that translate between activity data to OpenTelemetry span information. So here I'm attaching 4. I've got in-service bus for my messaging. I've got MongoDB, which is in my solution, but I won't show it today. I've got the request adapter, which is for ASP.NET Core. And the dependency adapter is kind of a hodgepodge of all the rest of the .NET Core stuff. So that'll include EF Core, it'll include HTTP clients. I think it'll include gRPC once that gets rolled out. And I think a couple others as well. So all of those are just either references here or additional packages. So I've got the exporters for App Insights, Jaeger, and Zipkin, the hosting extension to do services.whatever, and then finally the adapters for ASP.NET Core and for other dependencies. So let's run this whole thing and see what this whole distributed trace looks like. Now I'm actually using their MyGit feed for all this, so I can get like the latest, the absolute latest and greatest of these packages. These dependencies are on NuGet. They're just an older version that doesn't reflect the beta SDK that's been pushed out by OpenTelemetry. All right, so I've got console windows going with my different workers going. The worker service should pick up that message that we saw earlier that's just sitting in the queue. And a Chrome window should pop up here in a second where I can send some new requests down to have them get executed. Now, so today I've shown those extensions to those libraries as just code inside of here. And this is something I have to do if those library authors haven't extended or haven't exposed diagnostic information. So the hope is that those open source library authors start to include this kind of telemetry information and these adapters so that you can plug in without having to write this sort of infrastructure code yourself. But it's not there yet today, so I had to write it myself. Wasn't too terribly bad though. Okay, so web application is going, the child workers, that's Mongo junk. So I'm using an embedded form of Mongo to run the Mongo collections there. And then eventually something should pop up here. There we go. Oops, worker service. Going. Okay. I should have closed Slack before I did this. Worker service, web application going. There we go. Things are happening now. Okay. Hey, window popped up. So I'll send 2 messages. One is showing that first set of requests, and the first set of requests was showing a choreography style of messaging in the backend. And the second one was using, orchestration style. And the second one was using a choreography style. So this is hello, build stuff, execute, did the thing. And then the second one goes, say something else. Again, build stuff. Execute. Okay, so those 2 responses executed. Now let's pop open. Well, first let's make sure I actually got the messages. So my messages, I could see the final message actually gets received by the web application through RabbitMQ. I can see it did receive hello, build stuff, hello again, build stuff, and some other junk it pulled out from a database somewhere. All right, so let's look and see what that looks like in Zipkin first. So let me go ahead and refresh my search here. Aha, okay. Lots of stuff, and the CSS is wigging out with my zoom here. Okay, so I had 2 requests I sent. The first one was the orchestration style. And if I look at this trace, I can see now this is a trace that goes through an API call, goes through RabbitMQ, goes through RabbitMQ again, goes through Web API, goes to SQL Server. Another request gets sent. It gets out now to another child worker that gets sent out to MongoDB now, and then finally comes back to, at the very bottom, the web application. The single button click hit 3 applications like half a dozen times, and then finally resulted back in a overall trace at the end that told me that this thing was completed. And all along the way, I can look and see if I see one like a interesting details about that information. So I can see that, I don't know, this was, yep, all sorts of interesting information about the overall request and trace throughout the entire system. So if something goes wrong in this request, this will result in an exception getting thrown, and I can actually trace it back all the way to the request to the front end to see what it was that actually generated that exception. If I look now at the other kind, which was the, this one's a little bit different. So this one is a choreography style, which uses events. So in this case, the trace looks a little different because it's using pub/sub, and now I actually have multiple activities happening in parallel because I have 2 other processes subscribing to events, executing together before they come back together again. We finally surface that out back to the end application. So this can handle parallel activities as well. So you can see these 2 parallel activities are executing at the same time. And then can trace that all the way back out into the final application. It gets executed here at the very, very bottom. Yay. So that's Zipkin. Jaeger looks way better. So I go find these traces. Let's just look at the choreography style, which is this top one here. And the trace looks very similar. It's just kind of a nicer look to it, but it still has the same thing where I've got 2 parallel activities executing based on 2 events that got, or 1 event that got published to 2 endpoints. And then that did some more communication like MongoDB junk. And finally, at the very, very end, we get this final request at the very end that is the last piece in the process. Yay. Okay, so what we showed today, we showed, back to my slides. We showed W3C for, oops. We showed activities as the thing that can use to propagate information from one request to next. We showed the W3C trace context standard for standardizing what that the identifying information needs to look like. We extended some of our infrastructure components to be able to propagate that information out correctly. We use activities to surface diagnostic information in the form of diagnostic events. We used OpenTelemetry to listen to those diagnostic events. And then finally, we used the OpenTelemetry exporters to export that OpenTelemetry data to Jaeger and Zipkin in this case, but there's like a dozen different ways we could have done it to be able to visualize our overall distributed traces. So that was distributed tracing made relatively easy versus how it was in the past. If you want to see this code in action, this is all on my GitHub. So at the bottom, there's a link there that shows you can just download that solution and run the whole thing locally, provided you've got Jaeger and Zipkin also running locally as well. So that's all I have today. Thank you very much. I'll guess we have some time for questions.
Hey, thank you, Jimmy. How long do you think it would take me to learn this?
How long would it take you to learn, I guess, which part of it? Ideally, the only thing that you would care about is that last little piece where I say services.add OpenTelemetry, and then just configure the stuff. Ideally, like that, and hopefully in 6 months, that's where we get to. In terms of the other stuff, it took me probably a week or so to look at existing code to figure out how they hooked all these pieces up together. But now that there's a lot more examples, and you can look at this example as well, it's fairly straightforward to figure out how these different pieces pull together.
Mm-hmm. Okay, so do we have questions from the audience?
Yeah, I do.
Great.
So, Jimmy, to be honest, everything was not that clear for me. I should have already downloaded the code before I even follow the post. So basically, if I understood correctly, the activity API, basically we just have to start it somehow and end it somehow, and the activity API is already responsible to calculate all the metrics for us, so we don't have to do anything. Okay. So the question is more like, what about other metrics? For example, if you want to have the CPU, or maybe it's out of the context in this case.
Yes, so that is another part of OpenTelemetry that's going to be around metrics explicitly.
Yeah.
So the diagnostics API doesn't have anything for metrics at all, like whatsoever. So the idea would be that you as another infrastructure developer, or you as someone that wants to plug into infrastructure somewhere in your infrastructure code itself, that you would use this standard OpenTelemetry API to be able to record metrics. And then the exporters would be the thing that take those metrics and then push them out into whatever exporter that you want to have configured. That part is being done today. So I would go to the OpenTelemetry website, opentelemetry.io, and they're pretty well along in defining what those metrics APIs look like. They started with this, tracing, and now they're moving over to metrics.
Okay, I can continue if someone else. And about all the information, because I saw they are sent through the header. I mean, because I think that RabbitMQ actually have a kind of header, but it's not actually. My question is more like, is it part of the payload of the message, or it's more in the header type of things?
So it would be as part of the header.
Okay. And now maybe the last question. I saw that in your payload, in the sample, you have correlation ID as well. Do you think that they are served two different purposes, or it's just a kind of enhancement of the correlation ID which is sent on all the requests in the pipeline? Okay.
So some of the things I was using also have their own tracing information. So part of this is to say, I don't want to muck with any of the existing tracing capabilities that are there. I will add on top of it this OpenTelemetry tracing information. So I added on top of whatever tracing headers may exist already there, the W3C standard as part of that.
Okay. Thank you.
Anyone else?
I have a question there. It's how would you compare App Dynamics to Zipkin and Jaeger? My current client uses App Dynamics. I've used all of them. The decision about which one to use is never mine. It's usually like 8 levels above, made on a golf course somewhere. So I just say, pick, have someone pick something. And then hopefully this OpenTelemetry will plug into whatever that is. And they plug into like a dozen different kinds of these products. You can go onto the website and see all the ones they plug into. But otherwise, I don't really have a preference. Just use something.
Bill, do you want to ask for your?
Yes. Hey, Jimmy. One, this is awesome. I'd never somehow heard of trace context before, so thank you. 2, it looks like I was looking at W3C's implementations. There's a couple of them. There's like OpenTelemetry, OpenCensus. Is there a reason you picked OpenTelemetry explicitly? Just
yes.
To work.
OpenTelemetry is the successor to those efforts. So there was like an OpenCensus and Open something else before, and OpenTelemetry is combining those 2 efforts into one.
Okay, cool. Thank you.
So if someone has question, please unmute yourself. We have 10 more seconds for that.
What about legacy system? I mean, can you already introduce that, or did you already try to introduce that in legacy system? Because right now I'm working on a project for a client where we have a kind of distributed system, but the wrong way. We have the disadvantages, but not the advantage, because the bounded contexts are not well defined. But is it, in your opinion, is it useful to introduce such kind of thing to at least understand how the systems work? But we have like odd type of MVC application. We even have the old ISP, the core. We have really big legacy platforms.
Sure. So those, first of all, OpenTelemetry does have a hook for ASP.NET Classic, so to speak. So the next piece you would need to have is if those headers did not get propagated around, then you would have to write your own infrastructure code to do so. That's the bad news. The good news is there are places you could do that and hooks that exist to be able to put those header propagations in. So as long as you just did the same thing that the ASP.NET Core code is doing, then you can ensure that that information gets propagated through. And depending on the product you're using, like App Dynamics is a good example. They will auto instrument your applications as well to automatically put on those headers as requests get flown around. So if there's the way for you to do easy mode, you may have to pay for it. Like those aren't free products, but it's definitely worth looking into to see, can I just install something that automatically instruments my stuff, and then I can have that information flowing around throughout all requests to my system.